Hello, lecture laners. It's me, Dr. T, and today we'll be looking at some basic titration questions which you might see in your next exam. Please enjoy. So when solving any titration question, the first thing I'm going to want to do is write out a chemical equation. In this case, sodium hydroxide is titrated against acetic acid. So I'm going to do CH3COOH, which is our acetic acid, plus sodium hydroxide becomes CH3COONA plus H2O. So with any acid-base reaction, the typical scenario is that the hydrogen of the acid will swap with the cation of the base. The next thing I want to do is extract all the information from the question and write each piece of information under the relevant chemical. Now I check, is everything balanced? And yes, everything's balanced, so everything is in a 1-to-1 ratio. So we know the concentration of acetic acid is 0.502 moles per liter, and that the volume is 25 mil, or 0.025 liters. We know the volume of NaOH used to reach the end point is 0.0193 liters, and our concentration is what we're looking for. So my first step is usually applying the N equals CV formula. So I look at my data to find where I know both C and V, and that's for acetic acid. So we're going to apply the N equals CV formula to find out the number of moles of CH3COOH used up in our titration. So that's going to be equal to 0.502 times 0.025. And that will be equal to 0.01255 mole. Now, as previously mentioned, this is in a 1-to-1 ratio between the reactants and the products. So this is also the number of moles of sodium hydroxide. If that's the case, we can use the number of moles of sodium hydroxide and the volume to find the concentration. Again, using our N equals CV formula. So we'll have 0.01255 moles is equal to the concentration times by our volume. Therefore, C is equal to 0.01255 on 0.0193, which equals 0.6502 moles per liter. And that's to 4 significant figures, as 4 significant figures is the lowest number of significant figures in the question. So for the next question, again, we're going to write out the formula for the reaction between citric acid and sodium hydroxide. So the formula for citric acid is C6H8O7 plus sodium hydroxide will become C6H5O7 Na3 plus H2O. So the reason there were 3 sodium ions which transferred to the citric acid molecule is because citric acid is triprotic. And what that means is that it's able to donate 3 hydrogen ions as an acid. So therefore, they swap 3 hydrogen ions for 3 sodium ions. Now what this means is we need to balance. So balancing, I can see that there we need 3 sodium on the left-hand side, so I'll make 3 sodium hydroxide and then 3 H2O molecules. Next thing is to write down all our relevant information. So we know that there are 25 ml samples of the citric acid, so volume is equal to 0.025 liters, and their concentration are 0.1 moles per liter. And we know that the sodium hydroxide has a volume of 0.0415 liters. Now again, we're going to follow the same steps. So we're going to use our N equals CV formula to find out the number of moles of citric acid, which will be 0.0025 moles. Now, because citric acid and the sodium hydroxide are in a 1:3 ratio, that means that the number of moles of the sodium hydroxide is actually 3 times that of the citric acid. So if we multiply it by 3, we'll get 0.0075 moles. Now again, using our N equals CV formula, we're going to find out what our unknown concentration is. So 0.0075 is equal to the concentration times by the volume. So concentration equals 0.0075, 0.0415, which is equal to 0.181 moles per liter, to 3 significant figures. So for our final question, again, we're going to write out our chemical equation of our 2 reactants, which is sodium hydroxide and hydrochloric acid. So HCl plus NaOH reacts to form sodium chloride plus water. Everything is balanced, so everything is in a 1:1 ratio. I will then write everything we know. So the volume of the hydrochloric acid is 0.025. Its concentration is 0.1034 moles per liter. Our sodium hydroxide volume is 0.02575 liters, and their concentration is unknown. Using our N equals CV formula, we calculate that the number of moles of the HCl is equal to 0.025 times 0.1034, and that's equal to 0.002585. As everything's in a 1:1 ratio, that means that's also equal to the number of moles of sodium hydroxide. So therefore we can sub into our N equals CV formula. So N equals 0.002585, which equals concentration times by the volume, which is 0.02575. Our concentration of our NaOH will be therefore equal to 0.002585 over 0.02575. Therefore, it's equal to 0.1004 moles per liter, to 4 significant figures. So they're the basic steps to solving any titration problem. I hope this helps. Good luck with your studies, and I'll see you in the next video.